Hello students, this is Niteen Mohod and here we are going to see non-electrolytic capacitors. So far the capacitors are concerned, they are divided as variety of types, but mainly they are divided as fixed capacitors and variable capacitors. Here the meaning is fixed capacitors are those capacitors having their values fixed, while the variable capacitors are the capacitors whose values can be changed. Further, the fixed capacitors are classified as electrolytic capacitor and non-electrolytic capacitor. And the basic difference between the electrolytic and non-electrolytic is one is having polarity and another one is having no polarity. Means having polarity means when you are connecting it in a circuit, you will have to think of the positive and negative of the capacitor. While in non-electrolytic capacitor, it can be connected in any direction. There is no question of the polarity. First kind of the non-electrolytic capacitor that is having no polarity is a Mica capacitor. You can see how exactly the Mica capacitor looks like, and this is the internal structure of the Mica capacitor. Since it is a non-electrolytic capacitor, it has got no polarity, means it can be connected in the circuit in either way. How the Mica capacitor is constructed? So sandwich of several thin metal plates separated by thin sheets of mica. So here you can see the sandwich like structure where the metal plates of aluminium are placed alternately, and in between this represented by letter M, these are the mica sheets or mica plates. So mica being insulator, it works as a dielectric, and this aluminium, these are all the metal plates which are the best conductors. Okay, so alternate metal plates are connected together. As you can see here, the first aluminium plate and thereafter the directly third aluminium plate, they are connected together. And here on this side, the second aluminium plate and the fourth aluminium plate, they are connected together. And from these two plates, first and third, lead 1 is taken out. Right on the right hand side, from the second and the fourth aluminium plate, the lead 2 is taken out. So alternate metal plates are connected together, and leads for the external connections in the circuit actually are taken out. And total assembly of this, once this assembly is made, this total assembly is encased, means kept in a plastic capsule or bakelite case, and thereafter it looks like this with two leads for the external connection. Advantages of mica capacitor are they are having small capacitance values of the order of 50 to 500 picofarads. Picofarad means 10 raised to power minus 12 farads. So 500 into 10 raised to power minus 12 farad. Possesses high voltage ratings of about 500 volts. Stable performance and suitable for high frequency oscillation circuits. But these mica capacitors are superseded by the ceramic capacitors, and that is because of the qualities of the ceramic capacitor. And the qualities are they are economic in the sense they are low price capacitor, easily affordable, and excellent properties of the ceramics, which is used as a dielectric in ceramic capacitor. So moving on to ceramic capacitor. Here also you can see how actually the ceramic capacitor looks like with the coded value, and here you can see the actual diagram that how it is. You can say internal diagram of the capacitor, ceramic capacitor. It's a disc type, means this you can see in the figure, or hollow tubular shaped dielectric, means there are two types, you can say disc type and hollow tubular shaped dielectric, made up of ceramic material. Like now ceramic material, there are different ceramic material. Here we are talking about the ceramic material which is being used in a capacitors. So the materials are titanium dioxide and barium titanate. Thin coating of silver compound. Silver compound, as you know, silver is a good conductor of electricity. So thin coating of silver compound is deposited on both sides of the dielectric disc. Now dielectric is made up of ceramic, and on the both sides, from this side and the back side, on the both sides the thin coating of silver compound is provided, right? And what for it is so deposited on both sides of the dielectric disc, which acts as a plates of the capacitor. So silver coating on this side and silver coating on the back side, they will work as a parallel plates of the capacitor, and the leads will be taken out from them. Leads are attached to the both sides of the disc, and whole unit is encapsulated in a moisture proof coating. So this you can see is a moisture proof coating provided from the external side, and the capacitor actually looks like this. Due to very high dielectric constant of ceramic, now this is the property of ceramic, it is having very high dielectric constant, and that is represented by epsilon r is equal to 1200. These capacitors have very large capacitance of the order of 0.01 microfarad. Microfarad means 10 raised to the power minus 6 farads. So 0.01 into 10 raised to the power minus 6 farads as compared to their size. In a tubular form ceramics, there are tubular form ceramics, this is disc type ceramic. In a tubular form ceramics, the hollow ceramic tube has silver coating on both inner and outer surfaces. Here the capacitance varies from 1 to 500 picofarad with working voltage rating exceeding 10 kilovolts. So you can just imagine the voltage rating of this capacitor goes very high, that is around 10 kilovolts. Ceramic capacitor is more advantageous than mica capacitors, and that's why it supersedes the mica capacitor. Advantages of ceramic capacitors, some of the advantages we are going to see here. They are economical, as we already seen. Small size, hence requires small space and have large capacitance. Very high working voltage rating, just now we have seen. Low power factor means losses, which further decreases with decrease in frequency, and hence widely used for shortwave application in radios. Belongs to the category of non-electrolytic and hence have no polarity. I hope the idea of the types of capacitor, that is fixed and variable, and within fixed capacitor, electrolytic capacitor and non-electrolytic capacitor, and that to be specific, non-electrolytic capacitors like mica capacitor and ceramic capacitor is clear to you, along with their internal structure and their applications. Thank you.